linear equations. So let's look at a couple of ones. First, let's see how we can use standard form in applications. So let's consider the following problem. I have $10 and I want to spend it all on lottery tickets. And I have two favorite lottery tickets. The Happy Birthday tickets cost $1, while the Money Ball Bingo tickets cost $2. These are my two favorite games, and I want to spend 10 bucks on these tickets. Okay. So then let's come up with a linear equation in standard form that describes how many of each ticket I can buy. Cool. Well, okay, how do I go about doing this? I want to translate this into mathematics, and I think a good way of doing this is to sort of maybe write out a sentence that describes the problem and then sort of slowly translate it into mathematics. Let me show you what I mean. So I've got 10 bucks, I'm spending it all on Happy Birthday and Money Ball Bingo. So the amount of money I spend on, I'll just put HB for Happy Birthday, and the amount of money I spend on Moneyball Bingo is a total of $10. Let's turn this a little bit more mathy. So the money I spent on Happy Birthday plus the money spent on Moneyball Bingo has to equal $10. Okay, that looks more like a math equation, but it's basically the above sentence written down a little bit, half English, half math terms. Now I'd like to replace money spent on Happy Birthday and money spent on Moneyball Bingo into actual mathematical expressions. How do I do this? Well, let's do this a little more slowly. How much money do I spend on Happy Birthday? Well, each ticket is $1, so it's, let me keep the dollar sign there. So it's $1 times, the star will mean times, the number of Happy Birthday tickets I buy, plus how much do the Moneyball Bingo tickets cost? $2 times the number of Moneyball Bingo tickets I buy has to be equal to $10. Okay, that's getting us closer and closer to an actual mathematical equation. Well, finally I have to introduce x and y somehow into this equation. X and y are variables or unknowns or whatever you want to call them. What are sort of the variables or unknowns? The number of tickets that I'm buying. I haven't sat down and said I'm buying any specific number of tickets. All I'm saying is that I'm going to buy some number of Happy Birthday tickets and some number of Moneyball Bingo tickets and spend $10 total on them. So let's just call X the number of Happy Birthday tickets and Y will be the number of Moneyball Bingo tickets. Then replacing number of Happy Birthday tickets up here with X and the number of Moneyball Bingo tickets up here with Y, I end up with $1 times X plus $2 times Y is equal to $10. Or just getting rid of the dollar signs, 1 times X, which is just X, plus 2Y is equal to 10. Hey, that is a linear equation in standard form. Yay. Okay. Why don't we actually sit down and graph what this looks like, but, again, let's just say why this makes sense. This is the amount of money that I spend on Happy Birthday because I buy X tickets and I spend $1 on each. So the amount of money I spend is equal to the number of tickets I buy. Y is the number of Moneyball Bingos tickets I buy, and each cost $2, so 2 times Y is the amount of money I spend on that. I've got $10 total and I want to spend it all, so there we go. And that's what it is. Let's sit down and graph this. Okay, coordinate plane. I'm choosing my paintbrush. So let's actually plot x plus 2y is equal to 10. And let's do it by finding intercepts. To find the y-intercept, we set x equal to 0. And that means that we're left with 0 plus 2y is equal to 10, or 2y is equal to 10. And dividing both sides by 2, that leaves me with y is equal to 5. So this is my y-intercept right here at 5. Now to get the x-intercept, I plug in y equal to 0, and what I get then is x plus 2 times 0 is equal to 10. 2 times 0 is 0, so I'm just left with x is equal to 10, x is equal to 10. So that's right over here. So then the line I'm looking at goes from here to here. And that should be working. Here to here. There we go. That's the line I'm looking at. Now the line does extend up here, and it does extend down here, but I'm actually not going to draw it because let's note that in the context of this application, x should be greater than or equal to 0, and y should be greater than or equal to 0. Why? Because they are the number of tickets I am buying. I can buy no tickets, or I can buy some positive number of tickets. I can buy, Happy Birthday tickets, Moneyball Bingo tickets, whatever. But I can't buy a negative number of tickets. I can't go up to the bodega and say, here, I've got some Moneyball Bingo tickets, buy them from me. They're not going to buy them from me, especially if they just sold them to me. It's too bad. Okay, so we really want to be stuck in the first quadrant here to represent how many tickets we can buy. Another thing to notice is that x and y can't be fractions, so not every single point upon this line actually makes sense as a value. For example, this point right here would be 5, 2.5. I can't buy 2.5 tickets, I have to buy an actual full ticket. So again, this line doesn't, it goes through all the possibilities, but it also represents a few possibilities that don't make sense.